Welcome. In this session, we'll briefly review some computer-generated examples of approximating a function with a polynomial. Here we have our dynamical system that has an infinite number of minima, and I've restricted this to a small range, ranging from 0 to a very small value. And the little hash mark indicates where I've calculated the true minimum in this range to be. If we use T1, T2, and T3 as our points, that is, this is T1, this is T2, and this is T3, we then calculate the functional values that correspond to them, and we then fit a polynomial which produces a parabola using the techniques of the previous session. If we differentiate that second order polynomial and set that derivative to 0, we find the stationary point, the sole global minimizer for this, and this would be our estimate. We can see that the polynomial estimate is not too far off the true minimum in this range. That was an interpolation using 3 points. Next, we could say what happens if we just use T1 and T2 and we then give the derivative information at T1. Here we get a different but more or less similar polynomial. Here I've represented the derivative of the polynomial and therefore of the function at T1 as a solid line, and the dashed line is our parabola. Again, it's very easy to calculate the sole minimizer for this. The final numerical example we had was, suppose that we only have T1 and we have the first derivative and we have the second derivative all at that same point. What does that look like and what does that give us? Here, what it gives us is this is the point and this is the first derivative, and now the second derivative will completely describe the second order polynomial. So it will also have a global minimizer that is easy to calculate. We notice that we have 3 points, one derivative or 2 derivative as extra information, and depending on how we arrange this information, we're always getting parabolas, but the parabolas are differing slightly. In optimization, what we would typically do is we would select a situation in which we either have 3 initial points, 2 initial points, or only 1 initial point, and we would then run an iteration, and that is we would say, well, if this is the minimizer, what we'll do is we'll now try calculating it will now use a different point. So what we would do is we would use this point, and then we might get a minimizer, and what we would see is that we would gradually, under certain situations, we would gradually iterate towards the true minimizer of this function.